I'm here to explain why SQL, also known as SQL, should be your first programming language. So, what should your first programming language be? A lot of people might suggest C Sharp, which is what I use at work. Even more people would suggest something like JavaScript or Python, which are dynamically typed and interpreted. But the problem with all of these languages is that you're learning to code the algorithms. But what about learning to code data structures? So what are data structures? So let's look at something like a name and address form, which we've all used in web applications. The data structure is when you tell the computer what fields need to be saved and what type of data is going to be in each of those fields. Is it going to be text? Is it going to be a number? Is it so on? And this is what you're going to be doing in SQL, is coding the data structures, and this is a lot easier than coding the algorithms. So what are data structures? Well, I showed you the example of the name and address form. That's only one possible data structure for a name and address form. It could have other fields like zip code extension. So this is an optional part of the postal code that we have in the United States, where you'll see that some web forms have it and others don't. Another example is that the state field could have been a drop-down list instead of a text box, right? And that would prevent people from accidentally typing in an invalid state or pasting in an invalid value or something like that. So those are examples of how these data structures could be customized, and that's why companies are hiring software developers to create these customized data structures for them. Another example of a custom data structure could just be international addresses. So in some other countries, they have a different format for their address. Like when I lived in Amsterdam, they would do house number dash floor number, street name, and then the next line would have postal code and city. So what are some other data structures? Well, the name and address form is one that pretty much all companies need, and another one that all companies need is the invoice form, right? So here we have an example of an invoice form, and it's got 3 different line items in it. In each line item, we have the name of the product that was purchased, we have the price per unit, and then we also have the quantity showing how many units were purchased, and the amount is the total for that line. Below the line items, we have the subtotal and the grand total. And so this invoice form is a little bit more complex than the name and address form. Why is that? Well, as I said, one invoice has many line items, and it may not be 3 in every case. And in theory, there is no maximum of how many items a user can purchase on one invoice. And so those things, it gets to be very interesting as to how you're able to tell the computer how to save that data. And also, each invoice has a customer associated with it. So you have relationships between these 3 different data structures. There's the invoice itself, which customer it's associated with, and that customer could be defined by the name and address form in the previous slides. And then, so the invoice itself, the customer, and then the line items. So those are 3 different data structures that each have relationships between them as far as which ones are related to each other, and also is it like a one-to-one relationship, or is it one-to-many in the case of one invoice having many line items. So what are some other data structures that a company might need? Well, it depends on what information they need saved. So if you think of any company, what web forms would they need and what fields would go into those forms? That probably depends on what products they sell. So like a bookstore might need to save different information than like a furniture store. So like books might have some fields like maybe author or ISBN that don't apply to furniture, and maybe furniture has stuff like weight capacity that don't apply to books, right? or maybe it's a company that offers a service like a law firm. So then for them, they would maybe want to save stuff like who is the client meeting with, and what is the hourly rate for that person, right? So if the client needs to meet with a lawyer, that's going to cost them more than if they just need to meet with a paralegal, and so on. So those are the types of data that each company might need saved, and that's why you're going to be designing these different data structures as a software developer. And it's not only deciding what forms you're going to have and what those fields are, but it's also deciding the type of data that's going into each form. What does that mean? Well, text and number are the two most basic data types. Now, if you want, you could just save everything as text, but if there's a certain field that's going to hold a number, the computer can do more with it if you tell it that it is a number, right? So, for example, the zip code field. So here in the US, our postal codes or zip codes are 5-digit numbers, excluding the optional extension. So that's a field where if you did tell the computer that it's a number, that could help with validation and preventing invalid zip codes from being saved. In other cases, maybe if it's numbers that you want to use in a calculation, or you want to compare if one number is less than another, those are all things where you need to tell the computer that a certain field is going to hold a number when you design the data structure. Other data types could be date, which is a group of numbers. So that's a feature that SQL has built into it, providing that date data structure. You could have a drop-down list where the user has to make a single choice out of many possible choices. You could have checkboxes where the user can choose many choices out of many possible choices. Or you could have just a single checkbox for a true-false field. And for any of these fields, we have the question of, is it a required field? And then you get into the concept of null, meaning null means no value. So that's different from 0, and it's different from blank text, or at least in Microsoft SQL, it's different from blank text. So in conclusion, your first programming language should be T-SQL, also known as Microsoft SQL. Now there's many other versions of SQL, but why Microsoft? Because Microsoft is the easiest to use, both in terms of the syntax of the language being the simplest, and also the dev tools are easier to use with Microsoft, and the Microsoft documentation tends to be really good too. So those are 3 reasons why I would recommend Microsoft SQL over other versions. And with SQL, you're going to be designing data structures, and this is going to be a lot easier than designing algorithms, because with data structures, you're just telling the computer which fields to save and what the data type is. Whereas with algorithms, you're telling the computer which decisions to make, and it's a lot more difficult to make sure you've accounted for every possible scenario. That's what beginners have trouble with. So your homework for this video is to think of other forms that a company might need saved. So this would depend on the product or service being offered. So you could model this on some hypothetical company, or you could make it based on the company you work at for your day job or your side business, whatever you want. And go ahead and code the create table statements for that form. So you're going to have to Google how to do that. There's tons of tutorials out there. Go ahead and give that a try, and let me know in the comments how it goes. And if you want to see the video game that I coded, check out the link at the end of this video, and check out the link in the description as well. See you later.